Hello learner, welcome again to Manifested e-learning platform. My name is James Kenyani. We are going to go to the winding sessions of reflection and congruence. So at this juncture, our lesson today will be congruency tests for triangles. When I mean congruency tests, it means what would you look at in two triangles to say that they are congruent or they are exactly the same. So that's why the lesson goes congruency. Whatever you learn should have an objective. So usually in class you only look at it, but outside, how can that one help you? You can be at a manufacturing plant. They make similar things. They make congruent things. They could be triangular shaped mats. So you'll always have to consider, are they the same? That is in a factory. So the objective to enable the learner to know before determining whether two triangles are congruent. Two triangles are congruent. So without wasting time, we move to test one. Test one. It is written as SSS. SSS. All sides equal. All sides equal. And I'll use just the rhombus we used in the other lesson to demonstrate. We discovered that on reflecting, the upper triangle is congruent to the lower triangle. Lower triangle. When I say SS, this side is equal to this side. This side is equal to that side. And that common side is equal to both triangles. So before you determine in the first test that all triangles are equal, like if I have the first triangle A, I can have A, B, C. And I have corresponding sides should be equal, M, N, M. So what am I saying in to prove that this one is equal to? So for triangle ABC to be congruent to triangle MNQ, triangle MNQ, the corresponding pairs should be equal. A, B should be equal to MN. AB should be equal to MN. AC should be equal to MQ. And BC should be equal to NQ. That is the first test. SSS. All sides, all the three pairs of sides should be equal. All the three pairs of corresponding sides should be equal. We move to test 2. Test 2. Test 2. Test 2. Test 2. The second test to prove that there are equal. It is two sides and an angle. Two sides and an angle. Two sides and an angle. Some will write it as SAS. SAS. So for two triangles to be congruent, the corresponding two pairs should be equal and an angle. So we are going to look at that in a diagram. So if we have these, if you have L, P, S, and you have W, X, Y. They have talked of two sides and an angle. Two sides and an angle. The angle they are talking about is this one. That angle. They are talking about that angle. That angle. And the two sides are these ones. So you should be very careful what you note. So if I had marked, if I used these two sides, I would have marked this one and this one and this angle. Isn't it? If I used these two sides, I would have used this angle and this. But since I'm using this pair, I'll use where the two sides meet. At the vertice where that meets. So for triangle LPS to be congruent to triangle WXY, you come and say LP should be equal to which corresponding side? WX, comma, PS should be equal to XY, comma, and angle LPS should be equal to angle WXY. Learner, that is the second test. And I've just said I can also use these two sides. When I use this side, I'll refer to that angle. So it depends on the sides you choose. Test 3. Two angles and a side. Test 3. Test 3. They talk of two angles and a side. Two angles and a side. Many would like to call it ASA or A SA or two angles underside or AAS. 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 So it's good to have a triangle, the two triangles for us to understand. The first one is this one. We have to identify what they are talking about, two angles and a side. Two angles and a side. Two angles and a side. So if they talk of this angle and that angle, they have already got that angle and that angle. The side they would refer to will be OM. The side they will refer to, this will be the side. So it will be the side adjacent to the two angles. It will be the side adjacent to the two angles. So that is the side. So it depends what they take. If I had taken these two angles, the side I would use would be BM. If I had taken this angle and this angle, I would use OB. So it depends on the angles you choose. So for triangle, OBM to be congruent to triangle ECD. For that to be congruent, you see I've marked angle, side, angle. So to be congruent to ECD, angle OBM should be equal to CED, angle CED, comma, angle BMO should be equal to BMO should be equal to CDE, angle CDE, and OM should be equal to ED. That is a true test for congruency, two angles and a side. We look at the last test, right angled triangle, hypotenuse and a side. Right angled triangle, test 4. Test 4, the last test. Test 4. In test 4, they talk of a right angled triangle, hypotenuse and a side. It simply means the two triangles, the first case should be, they should be both be right angled triangles. So that's why we say right angled triangle, hypotenuse and a side, commonly known as RHS. RHS. S. It simply means the first consideration, the two triangles should be right angled. The two triangles should be right angled. So if I'm talking of A, B, C and C, D, F, C, D, F, the first consideration, are they right angle triangles? Yes. So if they are right angle triangles, you'll consider this one is the first one. Then the hypotenuse. Hypotenuse is this one. Note that when I come to side, I can choose any side. I can either say BA be equal to DC, BA be equal to DC, or AC be equal to CF. So for A, B, C to be congruent to CDF, triangle BAC and DCF should be right angles, comma, and a side, and SC should be equal to CF. Or you can come and say triangle, angle BSC and angle DCF should be right angled, and AB should be equal to CD. So you can choose any of the side. It will be a true proof. So we've gone through a recap of what we've done. In the first one, we looked at all sides should be equal. In the second one, two sides should be equal plus an angle adjacent to the two sides. In the third one, we looked at two angles and a side. Two angles and a side. And in the last one, you've looked at a right angle and one of the sides. 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 It will give you that, because if you project these, obviously this one will meet that one at the last vertex. So at that point, so as we wind up, there'll be an assignment for you. Assignment. In the assignment, the assignment is from KLB, exercise 5.5, number 6, 7, and 8. For those who don't know the KLB book, a KLB book, it is this one. It is actually the 4th edition. So if you go on that exercise, reflection and congruence, it is exercise 5.5, and you'll work out number 6, 7, and 8. And that learner will sum up the topic reflection and congruence. So thank you for your audience. Continue practicing, continue enjoying mathematics. Bye-bye.